Hi friends, this is Dr. Nitin Kumar Saxena. In previous lecture, we have discussed the method of Kirchhoff's law, and we have told you that how we can apply KBL and KCL for any circuit having the voltage source and resistance. So, like I'm extending my detail, I'm expressing the more knowledge for the applications of Kirchhoff's law, KBL as well as KCL, by giving you some example, and I'll try to solve two examples. And first example, we will solve the circuit having the voltage source only, while in second example, we will try to see that what would be the method when we have the current source along with voltage source in the circuit. So let us start with first example having voltage source and resistances. So friends, let's see the example that I am saying. We have some circuit like this in which we have, you can make any circuit, and you see, you can make any circuit according to your choice, according to your wish. Then you can try the method which I have told you, and again I am going to tell you for solving this KBL and KCL. And let's try to enjoy the methodology involved in using the Kirchhoff's voltage law and current law. So this is the circuit. If you're not happy with my circuit, you can do the problem with your circuit. But for this lecture, I'm doing with this circuit. Suppose the value of this 10 volt, this is 20 volt, this is 1 ohm, again this is 1 ohm, this is say 1 ohm or 2 ohm, or maybe 2 ohm, or okay, take it 4 ohm, right? So what we are doing, we are trying to solve the value, and we are trying to find the currents in the circuit and voltage also. This circuit has two voltage source, 10 volt and 20 volt, and resistances are 1, 2, 3, 4, 5. So 5 resistances. So the 5 resistances we have and 2 voltage source we have. So let us start with the recap which I have given you in previous lecture. First of all, we select any one voltage source. So let me allow to take this voltage source. You can do with this voltage source also, but like I have to take one, so I am taking this one. So I'll start with 10 volt voltage source, and we'll start to write the second step. The second step is now flow the current in the whole circuit. How can I flow this current in the whole circuit? Suppose I am starting with this and I am saying a I current is going out from this 10 volt plus polarity. What will happen? If I will go like this, at this point again the same I will come, right? When you will come to this point, at this point the I current is coming from here, so there is one diversion. So let I am saying here the current I1 is going, then the rest current will go here, so I minus I1. Okay, so I1 will go like this, again there will be I1 will go like this. At this point the current I minus I1 is coming from this side, so we will add both the currents, and the same current, what will happen? I minus I1 and I1 will give you I current. You see, the second point is completed, and which I told you in previous lecture, that if the same current is coming back, so this means your second point is okay, right? Now come to the third point. What is the third point? Show the polarity of each component in the circuit. So the polarity, showing the polarity of each component, you see in this 2 ohm, the current is going from this point to this point. So this is plus, this is minus, right? And this 2 ohm, the current is coming down, so this is plus, this is minus, right? For this, the current is going from this side to this side, so this is plus, this is minus. Similarly here, this is plus, this is minus, this is plus, and this is minus, right? If you want to show the polarity of voltage source, then you can show. Otherwise, there is no node. It's obvious. This is negative, this is positive, this is negative, this is positive, right? So no, this point is over. After that, now choose a closed loop and write the equation of KPL. So for choosing the loop, let me allow to give the name at all the points. So I'll start from this point. Suppose this is A, B, C, D, E, F, right? So now I'm starting to write the KBL for closed loop. Closed loop A, B, C, F, A. A, B, C, F, A. Right? A, B, C, F, A. And before writing the equation, I'll give you one more concept. That if you see this circuit and you try to identify how many unknowns you have. If you see this circuit, then number of unknowns are 2. I1. Okay? So since this circuit has only 2 unknowns, I and I1, so naturally, how many equations are required to solve this circuit? 2. So for this circuit, we will try to write the 2 equations, and therefore we will write the KVL equations for only 2 closed paths. So choose any 2 closed paths, that depends on you. You may choose any 2 paths, 2 closed paths, and for these 2 closed paths, you write the KVL equation. So let me allow for this A, B, C, F, A. So I am going starting from A, B, C, F, A. So you see, when I'm moving from A, B, C, F, A. So you see, first the voltage is 20. We are moving from positive to negative. So plus 20. Again, you come here. What is the value of voltage? IR. I is I1, R is 1. So 1 I1. Right? And what would be the polarity? We are moving from minus to plus. So minus. Is it fine? Again come here. The same current I1, value of the resistance is 1. So 1 I1, right? 1 I1, and since we are moving from minus to plus, so minus. Now come here. When we are moving like this, so we are coming on this. So the value of resistance is 4. The value of current is I minus I1. So what we will write here? I minus I1 multiplied with 4, and what would be the sign? Plus to minus. So plus equals to 0. Right? Now solve this. When you will solve this, what you will get? 20 minus I1 plus 4I minus 4I1 equals to 0. Right? This means 4I minus 6I1 equals to minus 20. We can say this is equation 1. Right? Now again, try to write the KVL equation for another loop. So now I am taking the loop E, D. Okay, so what loop I am taking? I am taking the loop E, D, C, F, E. Again, I am telling you that it's up to you. You can take any closed loop and any direction. You can go either clockwise or anti-clockwise. Totally depend on your choice. Okay. So for this, I'm writing again. So from moving from E again like this. So 2, what is the value of current into I? So 2I with, when we are moving like this, so plus 2I, come here from D to C again plus 2I, again come here, so plus 2 minus plus 4I minus I1, and you go there to when you go from F to E, so minus 10 equals to 0. Is it fine? We are moving like this, so plus 2 minus, so plus 2 times the current value I2I. Again here we are moving from plus 2 minus, so plus 2I, right? Here we are moving from plus 2 minus, so plus 4 times I minus I1, and then we are moving from here to here, so minus 2 plus, so minus, and the value is 10. Solve this. Solve again this, so 4I plus 4I plus 4I minus 4I1 equals to 10. So this would be 8I minus 4I1 equals to 10. This is equation number 2. For solving this, if I multiply the equation 1 with 2 and subtract from equation this, then we can cancel this I. This is called substitute. This is called the method in which we are what we are doing, the two variables we have I and I1, so we are nullifying the first variable I. How? Multiply this equation 1 with 2. So what we will get? 2 4s are 8 minus 12I1 equals to minus 40. Right? Now you subtract. When you will subtract, what you will get? This will cancel out. So this will be 8I1 equals to 50. So what is the value of I1? Is 50 upon 8. Right? Now substitute the value of I1 here, and in any equation, either 1 or 2, you will get the value of I. So like putting the value in any one equation. So I'm putting in second equation 8I minus 4I1 equals to 10. Right? So when I'll put the value of I1, so 8I minus 4, 50 upon 8 equals to 10. Right? So 4 2s are 8 and this is 25. So 8I is 35 and I will be 35 upon 8. Okay. So this means we have the value of two unknowns. What are these values? These values are I and I1. So I am putting the values at some place, and now you see we have I is 35 upon 8, and we know the unit of current is ampere, so I'm putting like this, and I1 is 50 upon 8 ampere. Right? Now you see, you know both the variables I as well as I1. So I'm asking you, okay, the value of current in this 2 ohm which is connected between E and D, right? So the current in branch ED, or you can say the current through this 2 ohm resistance. Since we have more than, so it may be confused that which one, this 2 ohm or this 2 ohm. So in place of writing the 2 ohm, I am writing the branch name. So the current in branch ED is what? I. So what is your answer? 35 upon 8 ampere. Right? Now I am asking voltage across branch ED. So what is the voltage? That will be, voltage value will be I into R. What is I? 35 upon 8. What is R? 2. So answer will be 35 upon 4 volt. Right? Similarly, we can find the value of voltage and current across any resistance. I am again taking the example of 4 ohm. So the current in 4 ohm resistance, current in 4 ohm resistance is, what is the current? I minus I1. So I minus I1. You know the value of I, you know the value of I minus 1. So 35 upon 8, 50 up minus 50 upon 8, this is minus 15 upon 8 ampere. Right? Similarly, the voltage across 4 ohm resistance, voltage across 4 ohm resistance will be 4 times I minus I1, right? So this will be 4 into minus 15 upon 8, so minus 15 upon 2 volt. So in this way, friends, we can find the voltage across any resistance and the current in any resistance. And the one thing you notice here, the value of current is negative. So this simply means that we are assuming the direction of current is like this. The current is flowing from the point C to point F. We are assuming. But since the answer is coming in negative, what does it mean? It means in actual circuit, the current is flowing from F to C. The difference is this. Okay, so never mind, value may be negative or value may be in positive. So negative means the assumption which we have taken as opposite. So the answer will remain same, the direction is different, that doesn't matter. Okay, so I hope you have understood how can we solve the problem using KBL and KCL if we have voltage source and resistance. Now same I am repeating the problem if we have the current source in the circuit. How we will use the KBL and KCL and what would be the difference when we have the current source in the circuit. So to see this, let me allow to replace any one voltage source with current source. So for this I am changing this 20 volt with some current source. So what will happen? Let's see through this example. So this will be our circuit. So for this circuit we will try to solve again with assuming that this is a current source, and the value of this current source is, I'm taking that the value of this current source is, suppose, 2 ampere. Okay, the same circuit I am using. The difference is that this circuit has one voltage source of 10 volt and one current source of 2 ampere. How can we solve for this circuit? To know this, let us start again the same concept. First, we will choose a voltage source. There is only one voltage source, or we can also choose the current source. So we can choose any source, and we will start to draw the current in the whole circuit. So we can choose this also, we can choose this also. So for simplicity, I am choosing this again. So if I choose this, so what will happen? If I choose this, then what will happen? Suppose, say the I current is flowing from this. At this point, I will be like this. So here I will be like this. Now at this point, what will happen? At this point, again, if you say that I1 is going there, so rest I minus I1 will go there, and I minus 1 will come like here. I minus I1, here I1, and again when you sum I1 and I minus I1, you will get I. Since the same current, again I am saying I current is going out, I current is coming in, and hence your second point is okay, right? If second point is okay, then come to the third point. What is the third point? You make the polarities across each circuit element. So if you draw the circuit element's polarity, current is going from this side, so this is plus, this is minus. Current is going like this, so this is plus, this is minus. Here, this is plus, this is minus, right? This is plus, this is minus, and here also this is plus, this is minus. Is it okay? This is over. Now the next point is choose closed path and apply KPL. Now there is a difference between the previous question and this question. You can note it that you can mark it, you can note it in your mind that a branch having current source, can not be cannot be involved for applying KPL. Hence, choose a closed path without branch of current source. So this is very important, that whenever you are solving the problem using KVL and KCL in a circuit which has a current source, then you must keep in your mind that you cannot use any such branch for applying KVL which has current source. So whenever you are choosing a closed path, you cannot choose a closed path in such a way then when you move in a closed path, there will be a branch having the current source. This is very important. So, like previous problem, if I take A, B, C, F, A, this closed loop, so what will happen? In branch A, B, we have this current source, and therefore this closed path cannot be considered for this numerical, for this problem. Is it fine? Similarly, we cannot consider this big closed path because when we are going for E, F, A, B, C, D, E, the same problem will occur. We will have this branch again AB, and this branch AB has current source. So we cannot use it again, right? So there is only one possible closed loop E, F, C, D, E, because this loop does not have any current source, so we can use it and apply KPL. Is it fine? Now I know what comes in your mind. In previous question, I told you that the equations should be equal to the number of variables. And here you are here in this problem only one closed path is possible. So one closed path means one equation, and you have two variables I and I1. So what you will do? This is something interesting. So the second equation will come through the logic which I'll tell you now. Okay. So what is that logic? The logic is, you see, you see the branch BA. In branch BA, a current source has the value 2A, right? The value of the current source is 2A. So current is 2. This is given. But according to my assumption, what is the current which is flowing in this branch BA? You see, the current is flowing I minus I1. I minus I1. So this is the current which I am assuming in branch AB, and this is the current which is given in the numerical. So it's possible only when these two are equal, and this expression will give you the first equation. Is it okay? And you see that this arrow shows the direction of the current. The direction of the current is same of your direction. If it is opposite, then we will take negative. But since the direction of current source is from this side to this side, and your current direction is also this side to this side, so what you will take? 2 equals to I minus I1. This will be your equation number 1. Or I am putting it and like this, that I minus I1 is 2. This is the equation number 1. Right. So if you know the equation number 1, then let us try to write the equation 2. So how can we write the equation 2? Simply using the closed path E, D, C, F, E. So if we use this closed path, so what will happen? So for this closed path, you start from E, so plus 2I plus 2I, again plus 2I, you go like this, so plus 4 times I1, plus, because we are moving from plus to minus, so plus 4I1 from F to E, minus to plus, so minus 10 equals to 0. So this is 4I plus 4I1 equals to 10. Right? Now you write the second equation by multiplying with first equation by multiplying with 4. What we are doing, we are multiplying equation 1 with 4. So 4i minus 4i1 is 8. Solve it, add this, 8i equals to 18. So I equals to 9 by 4, right? Now substitute this value here. So I minus I1 is 2. So what will be the value of I1 is I minus 2 equals to 9 upon 4 minus 2. So 1 upon 4. Right? So you write both the answers together over there. So the value of I is 9 upon 4 ampere and the value of I1 is 1 upon 4 ampere. So now you have the value of I and I1. So you can find the value of current across any through any resistance, and you can find the value of voltage across any resistance for the whole circuit. So I hope you understood how can we apply the KVL and KCL if we have voltage source as well as current source in the circuit. And I stop this lecture at this point. In this lecture, what I did, we simply have either voltage source or current source or both in the circuit. Then we can apply KVL and KCL and can find the solution for the circuit. Next class, in next video lecture, we will try to see how can we solve the problem having the dependent source, and before that, what are the dependent source, and how can we apply the KVL KCL if we have the dependent voltage source as well as dependent current source in the circuit. Okay, I hope it's enough for this lecture. So thank you very much. See you in next lecture. Bye.